Yeah, how are you guys everywhere, ladies and gentlemen? Today we are discussing, continuing on the series of the Mastermind sessions. So every 2 weeks we meet with of the software engineers here, and we talk about and discuss and share knowledge about various topics in Java. Last time, our speaker No spoke about the Java concurrency. It was a brilliant session. And today we have Tiago. He'll be talking about Java garbage collector. So Tiago, please go ahead and have a quick introduction about yourself, and let's get started.
Okay, so hello everyone. My name is Thiago. I'm from Brazil. Now I'm living in Portugal and I work with Java for almost 8 years. And today we will talk about Java garbage collector, that it's something that probably you are using and everyone that use Java probably are using the garbage collector. So it's an important thing that we should know at least a little bit how it works and why maybe we should not use the default one. So my name is Thiago again, and let's start. So we'll talk about four things. The first one is what is the garbage collector. Then we'll see how the GC works, if is there more than one GC, and also the JVM ergonomics. Okay, so let's start talking about what is the garbage collector. But before talking about garbage collector, let's talk about another important thing, memory leak. So what is memory leak? We can think memory leaks like silent killers that slowly gobbling up system resource until one day the entire application is faded. So they are killers. If you don't have a garbage collector or something to do the memory deallocation, our application will be out of memory and it will die. So this is the importance of garbage collector. The garbage collection is so the silent hero of memory management. He silent sweeps through the helm of allocated memory, freeing the forget fragments and sparing developers from the shackles of manual memory deallocation. So garbage collector is basically our hero. We don't need to know about them usually because it's, like I said, a silent hero that help us to avoid memory leaks. But it's very important to know at least a little bit how it works because maybe use the default one, it's not the best choice. And just a joke, not sure if is memory leak or just many instance. So uh, I don't know if you have already having the out of memory error is usually from when we don't have uh, more space in Java heap, and it can happen with so many reasons. Okay, if you have so many instances and you have just a few free space, maybe you can get this type of error. It's very annoying. And there are, of course, another reasons, okay, that can help to have memory leak. Garbage collector try to help us, but we also need to be careful about some of the common problems related with memory leaks. Okay, so now let's talk about how the GC works. Okay, so let's understand how the GC helps us to avoid that type of problem and how it works, how the GC clean the memory. So before talking about the GC, we need to understand the heap. Okay, the heap it's basically the memory that we allocate for the objects, and we have free space, okay? We have the young generation and the old generation and the permanent generation. The young and the old generation, it's part of the heap. The permanent generation, let's keep it on the side and we'll talk about that later. As you can see, on the young generation, we have the hidden and S0 and S1 space, that is the survive space and the add-in space. And now let's talk about the young generation, okay? So let's keep the old and the permanent generation on side and let's talk about the young generation and how garbage collector works. So the first thing is when we create an object. So we create a new instance, new object. So okay, we have the object. The object will be created in the add-in space, okay? Just that. And after that, when the garbage collector runs, if the object still have a reference, it will move to the survive space. Otherwise, it will be cleaned, okay? So the GC run every time, okay? I will talk about that later, but it's always running. And if you have the reference for the object, it go to the survive space. Otherwise, it will be clean. Okay, and how about the survive space? What is that? Okay, so you have two survive space, and the objects start to pass to one from the other if the garbage collector is running and the object has a reference. So in this case, let's say that the garbage collector is running and we have objects in SO survive space, and this object still has a reference. So we have the object aging. This means that this object has like a variable, let's say that it's the age of this object. And all these objects from the survive space 0 will be moved to the other survive space, and this age will be incremented, okay? And this will keep happening, and we'll have more additional aging, and this will keep happen. If the object don't have a reference, it will be cleaned. Otherwise, it will be moving to one survive space to the other until they get the retirement, okay, or promotion. Basically they will left the survive space and they will go to the old generation. And when this happens, in this case, the age it's 8. So after that, they will go to the old generation and they become part of the old generation. So just looking for that, okay, the retirement, or actually it's promotion, the real name. I just bring retirement just as a joke because I think after all these years they deserve the retirement. But basically, they go to the young generation, old generation. Okay, this is the promotion, and this happened after changing to one survive space to another so many times. Okay, and okay, we talk about the young generation, how it works. Now, let's talk about the old generation. And how about the old generation? How it works? It's the same thing. What is that? But before talking about the old generation, let's talk about one very important thing, that is the STW, or stop the word. Here we can see the serial GC. We have the GC thread. This means that we are executing the GC, and we have the stop the word. The stop the word basically means that the entire application will stop running, stop all the threads, and we execute the garbage collector. So STW is a problem when we are talking about latency. And what is latency? Well, latency is a measure of how long a single task takes. We can also think in lag in the games. Just a joke in here. Why I lose online games? Because the other players are better than me. It's just 1%. The 99, it's because of the lag. And lag, it's caused when we have some latency problem because the application is overloaded, or usually because you have a connection problem, right? So this is latency, okay? And when we are talking about latency, we have another important thing that is throughput, okay? They are really close between them, and we need to think and know both, okay? So throughput is a measure of how many tasks an application can simultaneously handle over a period of time. And this is just a joke. Not sure if a slow computer or just Java. This is just a joke, okay? So throughput is also very important. And let's see the difference between them here in the image, because I think it will be easier to understand the difference between them. And it's very important to understand them because in the next slides, I will talk more about latency and throughput. So what is throughput? Throughput will measure the amount of data that can be processed in a period of time. Here in 1 second, for example. And latency will measure the amount of time it takes to perform a given process. So let's see another image just to make it more clear. So here on the top, we have latency. That is the time that need to transfer up to a package, to execute a package transfer. And then we have the throughput, that is the quantity of data that can be sent in a given unit time. Okay, so it's very important to understand both latency and throughput because they are really related with GC. Okay, and I will again talk about that in the next slides. Okay, so let's talk again, let's get back to the old generation. Is old generation clean? How this works? What is, we see the young generation? How about the old generation? So let's see the old generation for the CMS. Okay. So we have a lot of STW executions. Actually, have two phases that it's STW, stop the word. This means that the latency will be high because all the application will stop. And we have basically the initial mark, that it's a short pause phase where live objects are marked, and also the finish mark or remark phase, which serves to find the objects that were lost during this concurrent mark. And after that, the objects that don't have a reference, they are cleaned, and this clean is executed. It's not a STW, okay? It's executed in parallel, and it's okay. Before I explain more about that, I want to ask you a question. How many GC exists? How do you think? What do you think? Two,
I think
three?
now
Go
there are
ahead.
5 because there are 2 new ones being implemented. It is the parallel, sequential, G1, Serandon, and then this low latency garbage collector, at least 5.
5D?
I think it's more than five.
Or more than
E?
5, yeah.
More than
Okay,
five. Yes.
so
E,
yes.
last one. E.
Okay, so you are correct. We have more than 5. I will show them later. Okay, but you have more than 5 GCs. Okay, and of course, a private company can create a GC. So we have more than 5 GCs that it's created and available on the OpenGTK, in the OpenGTK, but we can also have private garbage collectors. Okay? But why I show this now? Because now we talk about G1. We talked before about CMS, but now let's talk about G1, okay? So G1 heap allocation, it's different. Before you see that you have a specific space for the add-on, for the survive and old generation. Now with G1, it's different. We have a lot of regions, okay? It can be the maximum, it's 2000 and something. And each region can have size between 1 to 32 megabytes, okay? And how this works, one version can have hidden space and old space and all work together. And this, it's very important how the garbage collector works, right? Because all of them works in a different way, but everything that I have shown you before until now, it's basically the same, okay? We continue having the added space, the survive space, the old generation, the promotion, it's the same. It's basically the same thing, okay? Just the space that now it's different. And of course, when we are talking about the old generation, the garbage collector that runs through old generation, it's also different, okay? Sorry about that. The slide it's wrong. Here it's old generation for G1, okay? This is the old generation for G1, as you can see below, garbage first G1 collector. So G1 works different when you're talking about the major GC or the GC for the old generation. We have, in this case, free stop the word phase, and G1, it's actually I will not say that now. I will say later. Okay, I will not give you a spoiler. But G1, let's say that is best than CMS. Okay, for now it's that. We should not use CMS anymore, and I will show you later about that. But G1 works different. I will not explain how it works, okay? I will not go deep on it, but it's very important to understand that you have different type of executions from one to another GC, okay? The GCs works different for different reasons, and I will show it later. Okay, and how about the permanent generation? Are the objectives promoted to permanent generation? There is another type of promotion. What do you think? Well, permanent generation or metaspace, okay? Before Java 8, since Java 8, the name permanent generation has been replaced by metaspace. And the metaspace and permanent generation is intended for metadata that represent such class, methods, things like that. And this metadata is allocated when the corresponding Java class is unloaded, okay? This happens when the GC is executed, okay? And we can also configure it if you need it using this parameter max the space size, okay? It's very important to understand a little bit, to do some tests to identify if you really need to change it. But if you want to, you can. Okay, let's move on. So is there more than one GC? We have already answered that. And yes, we have. Here we can see that just in this slide, we have 7, okay? But one of them are the CMS, okay? So let's talk a little about them, okay? So let's start talking about serial GC, okay? Serial GC is just a single thread to run GC. It's recommended for machines with one CPU and with really low memory, like 100 megabytes, it's recommended for client class machine applications. So applications that have a single user, okay? And if you want to use serial, you can do with this parameter, okay? Let's move on and talk about parallel GC. Parallel GC, different from serial, here we use multi-thread to run GC. It's recommended for applications with medium and large size. And if you are using Java 8, this is the default GC for Java 8 and previous versions. It's recommended for applications that focus on throughput. Okay. Later I will show you when you should use parallel, because yes, we will still have parallel and maybe it can fit well for your application. And now let's talk about CMS. CMS, I don't talk a lot about that because it's deprecated, was deprecated in Java 9 and was removed in Java 14. Here we have some JEPs if you want to search more about it. And it was replaced by G1. So let's talk about G1, that it's more important. So I said that if you're using Java 8, the default GC is parallel GC. But if you're using versions 11, 17, high versions, now the default is G1, okay? And G1 GC also use multi-thread to execute the GC. Sorry about the slides, it's in Portuguese. I don't realize that, I just realized that now. Sorry about that. But okay, keep moving. So the GC, it provides why GC G1? It's the default now because it have it provides throughput and latency. It works well with both, and it's also recommended for application that want to have a balance between them. Okay, so this is the reason why it's the default. Okay, because latency maybe it's more important than just throughput. Okay, and you can use this G1 using the use G1 GC. I said that this is the default, but later I will show that maybe this is not the default. Okay, it will depend, but let's keep moving. So the next one I will talk about it's ZGC. Okay, ZGC, it's a GC that, sorry again, it's in Portuguese, I don't realize that, but okay, ZGC, it's a GC that it's the main focus, it's the latency. Okay, it was available on JEPs that it's high, it's available for Java versions that high from 15, and this is the JEP 377. The ZDC has a different thing. It don't separate the young and old generation. And one of the main objects, one of the main reasons for ZDC, it's to have a really, really small pause times, lower than milliseconds. It's microseconds. It's very, very low. So if latency is a problem, maybe ZGC is the best option. But again, we need to use Java 17 or high versions if, of course, you want to use LTS version. Okay, and it also supports small and high applications with just single megabytes or with terabytes. Okay, and you can use it using use ZGC. Okay, now let's move on. I will not talk about Shenandoah. Okay, Shenandoah has also it's also have a main reason related with the main reason for Shenandoah, it's latency, but we will not talk about it because we also have the ZGC. Okay, Later, I'll show a little bit about Shenandoah, but if you want latency, if you want really a small latency, maybe ZC will fit well. But we'll talk about that later. How can you choose the best one for you? So let's talk now about Java ergonomics. Until now, we have any questions? Otherwise, I will keep moving and I will keep the questions for the end. Okay, so I will keep moving and I will keep the answers, the questions for the end. Okay. So which GC will the JVM choose? What do you think? Serial, G1, parallel, ZGC?
By default is G1, but it depends on the hardware too. As you said, if you have a very small machine, it will probably switch to serial automatically if you're running a container or something like that.
Yes, great. So yes, your answer is right. So the correct answer here is depend. And like everything in IT, it depends. And so what you see with the JVM choose? If you see the code of the JVM, we have that talks about what is the server class machine. If it's a server class machine, the default will be G1. Otherwise, will be the serial. And we can see here in this comment that basically if you have more than 2 physical CPUs and more than 2 gigabytes, it is considered a server class and it will use G1. But let's go deep in the details. So if it has 2 processors and more than 1792 megabyte, it is considered as a server machine, and G1GC will be used. Okay. Otherwise, if it has up to 1791 megabyte, it is considered a client machine, and serial GC will be used. So again, it depends, but it's really important to know that because if you are running a microservice, maybe it will use the serial C. Serial C for latency is the worst one. Okay, the garbage collector for serial C, it's just to stop the world. It doesn't have any type of improvement related with latency. So maybe if you're running a really small application in a container, make sure if serial C is the best one for you. Otherwise, if you don't define the GC, it will be serial C, and maybe you have some problems with latency. So okay, now maybe you have a question to ask me, that is, which GC should I use? And the answer is very easy. It depends, like everything in IT, but I'll try to give you a better answer than it depends. Okay, so now I have a lot of information. I'll try to make it easier to understand, but of course you can pause and see this later. And this is also shared in Microsoft blog. Okay, so here we have, if you're using, like I said, small applications, just a single client, okay, one client, it's a client machine application, serial C is the best one. If you really want to have high throughput, parallel C can be the best choice. So if you have, for example, batch workloads that you don't care about latency, you can go with parallel C. If you want like a moderate related with latency and throughput, G1 maybe is the best one. So again, it's the default one. And if you don't know what to choose, go with G1 and then try to turn G1, try to understand why you need something, and then you can change the GC. G1 usually work well for the most of applications. Go to ZGC if you really want a low latency application. The ZDC have less than 1 millisecond of pause times. I think now in the later versions, it's really small. It's microseconds. It's really speed. It's really fast. So if you want low latency, ZDC maybe is the best choice. And Shenandoah. And how about Shenandoah? Shenandoah has a different thing. If I'm not wrong, ZGC has a low latency, okay, if you compare with Shenandoah, but Shenandoah has the same latency if you have a high or a small heap. We can have a heap, for example, with 2 megabytes or 200 gigabytes, and the latency for Shenandoah will try to be the same, okay? Shenandoah works well if you want to have the same latency independently of the heap size, okay? Okay, now I hope that you understand at least a little bit when to choose which one. And again, if you don't know which to choose, go for G1GC, try to understand your application, your needs, and maybe you can then change the GC, okay? And again, try to don't use the default. The default can be serial C if you have a small application, a small machine with just few megabytes or less than 2 gigabytes as we saw before. So be careful with that. And least but not last, I will show you some things that you can use for G1 if you want to tune the G1, okay? The other garbage collectors will be different. I will talk about G1 because it is the default one, okay? So the first thing, you can change the max GC pulse milliseconds, okay? You can change it, you can increase it or not. If you increase the max GC pulse, you are saying to a garbage collector that you want to execute fewer, and this, it will help you to increase the throughput. If you have a small size of pulse time milliseconds, it will increase the latency, okay? So again, it's a balance between them. You need to know what you want, more throughput or more latency, and you can change that. This doesn't mean that it will take 200 milliseconds. It's like a tip for JVM, and JVM will try to reach that, okay? Another thing that can help, okay? You can use the G1 heap waste percent, and basically here, the G1 stop the space reclamation, the garbage collection phase, in the free space in the collection set candidate is lower than that. So if you don't reach this percentage, the space reclamation phase will not be executed. Another very important thing here, okay, because if you're using, for example, Java 8, and you're using XMN to configure the young generation size, you should not do that if you're moving to use G1, okay? You should not use XMN or new ratio to configure the young generation for G1. If you want to configure the young generation, you can use the variables that I show below, that it's G1 max new size percent or new size percent just, okay? And yeah, it's that I have to show, okay? If you have any doubt, you can ask me now, or you can reach me and ask later. Okay, it's that. Any doubts? I hope I've understood a little bit more about GC. I hope I have bring some value.
Yeah, it's really nice. Yeah, thank you so much, Mr. Thiago. It was a really good presentation. That's so many topics that were really like covered for us. You made it clear and uncovered for us.
Yeah,
So any
very good
questions for the audience? Let's see if there's any question so far. I think there is no question so far. Would you like to share something, Mr. No?
Yeah, well, I have a question actually. On the comparison of the garbage collectors, you talk a bit about the overhead, right? Do you know which one is more CPU intensive than the other? Because you see the overhead, they have moderate, G1, CGC, and Serendon. But is there much difference between them in terms of CPU intensive usage?
Yes, I haven't done any type of benchmark, and I also haven't searched for that, so I don't have. I think I'm not able to answer the best answer for that. But again, Shenandoah probably will be the worst one if you're talking about that, because Shenandoah will try to read the actually the same millisecond independently of the Java heap size. So, of course, if you have a big heap size, probably we don't have a huge problem with CPU. But if you have a small heap size, maybe it can be a problem. Okay,
Okay, good.
you need more CPUs. Okay. But again, this is the balance between throughput and latency. Okay, if you have huge memory, huge CPU, a lot of cores, a lot of memory, probably we don't have problems with throughput or neither with latency. Okay, we can use, for example, ZHC or Shenandoah that really works fine, but it's not the most common scenarios, right? We usually have a small number of cores and small number of size heap. So because of that, we need to understand what we want, throughput or latency. Okay,
Yeah, great,
so
thanks.
it's
Thanks,
basically
Tiago.
that. Uh, any more question?
How about Mr. Tiago? How about nowadays, we ship our Java application along with Spring in a Docker image, okay? So now how the JC will work along with Docker image, because the Docker image, we specify that uh, one, one GB RAM maybe, or sometimes maybe 512 MB RAM. So will the GC take the Docker file, Docker instance RAM, or it will take the host RAM? Or because we run the Docker with the along that we use. So which one will how Java will work in this scenario? I hope you got the scenario that I'm trying to describe.
No, sorry. Actually, I don't understand the question. You are saying that you are
Yeah,
running more than one container in a single, let's say, pod or VM. It's that
yeah.
in a single
Yes. For example, see
JVM.
when yeah, see, no, I'm running my Java application, okay, in a Docker file, okay, in a Docker file. So I will specify from, for example, Open Java 17, okay.
Okay, okay,
So then I will also, one of the attributes I can give it to the Docker, that you Docker or you pod, you can allocate memory up to 1 GB RAM.
Yes.
So now the garbage collector will take these attributes, or it will neglect the Docker image or Docker instance, and it will take the host attributes.
No, it will take from the image, okay? It will take from the what you define on the image, okay? Let's think about, for example, Kubernetes, okay? In the Kubernetes, in the environment,
Yes.
we have, for example, let's say that our cluster have, I don't know, 20 gigabyte of memory. And we have a deployment that are using just 1 GB. So it will use just a single, just 1 GB, right? So it will define the JVM will define it based on the rules that you define on, in this case of the pod, on your YAML file. So if you define just 1 GB, it will be just 1 GB. Okay. Actually, the heap will be less than 1 GB. It will be half because it's 1 GB. There is rules for that. If you have more than, I prefer to don't try to guess. I think it's more than 4 GB. Uh, it's just 5%, but I'm not sure about that. But you should not depend on the JVM to decide your heap size. Okay, you should also define that. You should define your heap size and also the garbage collector that you want to use. Because if you don't do that and you are running a microservice really small and you cares about latency, maybe using serial.c it's not the best choice. But again, it's a trade-off, okay? If you have 100 of requests at the same time, it will increase the latency because probably you need to run the garbage collector and it will increase the latency for all the calls. And if you have a small machine that you are not able, you can use, for example, Shenandoah, that it will try to have a really small latency time, but will increase the throughput. So you'll not be able to respond, for example, 10 per second. You respond 5 per second. So it's a trade-off. You really need to understand what's best for your application. If you have, for example, HPA, horizontal pod outscaling, I don't know, maybe if you have that and you are able to outscale it very fast and start very fast, I don't know, maybe Shenandoah will work fine in this case that I said before. But again, you need to measure. You need to do some verifications and check which one is the best. Here it's just some tips, okay, to try to identify which one is the best. But I think the goal here is to understand that we have more than one C, and the default can be one that you don't want to be, like serial C. Maybe you don't want serial C for web applications with many users.
Yeah, brilliant. Thank you so much. So any other questions, guys? I think no questions so far. So I would like to end this session that is really done beautifully by Tiago. I really thank you so much for your presentation, and thanks so much for the audience for your coming and patience. So let's see you next time, guys. See you guys.
Yes, thank you,
so
Claudio.
much.
Thank
It was
you.
great. Cheers.